According to the National Electrical Code, NEC, Article 440.14 addresses disconnecting means for air conditioning and refrigerating equipment. Paragraph A, General, states that where one or more disconnecting means are required for air conditioning and refrigerating equipment, the provisions of 440.14 shall apply. Paragraph B, Rating and interrupting capacity, specifies that the disconnecting means shall have a rating not less than the ampacity of the branch circuit conductor supplying the equipment and an interrupting capacity not less than the maximum fault current available at the terminals of the disconnecting means. Paragraph C, Location, mandates that the disconnecting means shall be installed at a readily accessible location outside of a building or structure or in a room or enclosure where the equipment is installed. Paragraph D, Number of disconnecting means, allows one of the following to serve as the disconnecting means: firstly, a single disconnecting means; secondly, multiple disconnecting means; and thirdly, a combination of disconnecting means for all or some of the equipment and other disconnecting means for remaining equipment. NEC 110.26 covers marking. Paragraph B, Locked or guarded, states that where live parts are guarded or locked so as to require a tool to open the enclosure door or cover shall be marked with a warning label reading "This cover is to be kept locked or guarded." Such interlock shall be maintained while energized. Based on these NEC requirements, the breaker lockoff by itself typically does not meet the requirements of a disconnecting means. One reason is that it is often not considered a permanent installation. Another reason is that it may not provide the necessary interrupting capacity. Additionally, if a breaker lockoff is used, it must be marked with a warning label indicating that it must be maintained locked while energized. Therefore, a request for a breaker lockoff as a substitute for a disconnect may not comply with the NEC. A permanent, readily accessible disconnect, such as a no-fuse disconnect, is often required for a safe and compliant installation. To reiterate the key points, consider the requirements for disconnecting means for air conditioning and refrigerating equipment as outlined in NEC 440.14. This section emphasizes the importance of having a readily accessible and appropriately rated disconnecting means for such equipment. The disconnecting means must be rated to handle the ampacity of the branch circuit conductors and the maximum fault current available. It must also be located in an accessible location, either outside the building or within the room or enclosure where the equipment is installed. While multiple disconnecting means are permitted, they must collectively meet the requirements for disconnecting all power to the equipment. The use of a breaker lockoff as a substitute for a dedicated disconnect is questionable under the NEC because it might not provide the required interrupting capacity. The interrupting capacity of a disconnect is the maximum fault current that the device can safely interrupt without failing, and it is a critical safety parameter. A standard breaker lockoff might not be rated for the potential fault current, particularly in systems with high available fault currents. Also note that NEC 110.26b addresses the marking requirements for enclosures with live parts that are locked or guarded. This section necessitates a warning label indicating that the cover must be kept locked or guarded and that the interlock should be maintained while energized. This requirement highlights the importance of maintaining the integrity of safety measures. It is essential to understand the difference between a breaker lockoff and a dedicated disconnect. A breaker lockoff is a device that mechanically prevents a circuit breaker from being switched on. It is typically used for maintenance or lockout-tagout procedures where equipment needs to be energized for safety. A disconnect, on the other hand, is a switch designed to isolate equipment from the power source. Disconnects are typically rated for continuous use and are designed to interrupt the full load current of the equipment. They provide a more reliable and robust means of de-energizing equipment. Consider the specific requirements for the heat pump installation, which includes 15 kilowatt heat strips operating at 240 volts, single phase, with an 80 amp feeder protected by fuses. In this scenario, the disconnect must be rated for at least 80 amps and must have an interrupting capacity sufficient to handle the available fault current at the installation location. A breaker lockoff, even if used on an 80 amp breaker, might not meet the interrupting capacity requirements. The NEC prioritizes safety and accessibility in electrical installations. The requirement for a readily accessible disconnect ensures that maintenance personnel can quickly and safely energize the equipment in case of an emergency or for routine maintenance. The location requirements in 440.14c stipulating that the disconnect be located outside the building or in the same room as the equipment are intended to facilitate easy access and prevent delays in de-energizing the equipment. When evaluating the acceptability of a breaker lockoff, consider the following points. Firstly, interrupting capacity. Does the breaker lockoff have an interrupting capacity rating adequate for the available fault current at the installation location? Secondly, permanence. Is the breaker lockoff a permanent installation or a temporary device designed for lockout tag-up procedures? Thirdly, accessibility. Is the breaker lockoff readily accessible to maintenance personnel? Fourthly, marking. Is the breaker lockoff properly marked with a warning label indicating that it must be maintained locked while energized? And fifthly, compliance with NEC 440.14. Does the breaker lockoff meet all the requirements for a disconnecting means as specified in this section? To further clarify the requirements, let's consider some additional aspects of disconnect selection and installation. Firstly, the type of disconnect required depends on the specific application and the equipment being served. For heat pumps and air conditioning equipment, a non-fused disconnect switch is commonly used. This type of disconnect provides a reliable means of isolating the equipment from the power source without the need for fuses. Secondly, the disconnect must be properly sized to handle the load. The ampacity rating of the disconnect should be at least 115% of the nameplate rating of the equipment it serves. This ensures that the disconnect can handle the continuous load current without overheating or failing. Thirdly, the disconnect must be installed in a readily accessible location. The NEC defines readily accessible as being capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. Fourthly, the disconnect must be properly labeled to indicate its purpose. The labeling should clearly identify the equipment that the disconnect serves. Fifthly, the installation must comply with all applicable codes and standards, including the NEC and local electrical codes. This ensures that the installation is safe and meets all regulatory requirements. In summary, when installing a heat pump with electric heat strips, a dedicated disconnect is typically required to comply with the NEC. A breaker lockoff might not meet all the requirements for a disconnecting means, particularly regarding interrupting capacity and permanence. Always consult with a qualified electrical inspector to ensure that the installation meets all applicable codes and standards. It is crucial to understand the specific requirements of the NEC and local electrical codes when installing electrical equipment, especially when it comes to safety devices like disconnects. The use of a breaker lockoff as a substitute for a dedicated disconnect is often a point of contention, and it is important to be aware of the potential risks and liabilities associated with non-compliant installations. For instance, consider a scenario where a heat pump fails and needs to be serviced. If the only means of de-energizing the equipment is a breaker lockoff, and the lockoff is not properly maintained or is easily bypassed, there is a risk of electrical shock to the service technician. A dedicated disconnect provides a more reliable and safer means of de-energizing the equipment, reducing the risk of accidents. Additionally, non-compliant installations can lead to insurance issues and legal liabilities in the event of an accident or equipment failure. If an installation is found to be in violation of the NEC, the property owner could be held liable for any damages or injuries that result from the non-compliance. Furthermore, insurance companies may deny coverage for losses resulting from non-compliant electrical installations. Therefore, it is always best to err on the side of caution and ensure that all electrical installations comply with the NEC and local electrical codes. Consulting with a qualified electrician or electrical inspector can help ensure that the installation is safe, compliant, and meets all applicable requirements. Now consider the perspective of the heat and air contractor who is suggesting the use of a breaker lockoff instead of a dedicated disconnect. The contractor's motivation might be to save money on the installation. Dedicated disconnects can be relatively expensive, and the contractor might be trying to reduce the overall cost of the project to make their bid more competitive. However, it is important to recognize that compromising on safety to save money is never a good idea. The cost of a dedicated disconnect is a small price to pay compared to the potential risks and liabilities associated with the non-compliant installation. Explain to the contractor the importance of complying with the NEC and the potential consequences of using a breaker lockoff as a substitute for a disconnect. Emphasize the safety benefits of a dedicated disconnect and the potential legal and financial risks of non-compliance. Be prepared to provide documentation and code references to support your position. If the contractor is unwilling to budge, consider walking away from the project. It is not worth risking your reputation or license to install a non-compliant electrical system. To further illustrate the importance of proper disconnect selection, let's consider some examples of different types of disconnects and their applications. Firstly, non-fused disconnect switches are commonly used for air conditioning equipment, heat pumps, and other motor loads. These switches provide a reliable means of isolating the equipment from the power source without the need for fuses. Secondly, fused disconnect switches are used in applications where overcurrent protection is required at the disconnect location. These switches incorporate fuses to protect the equipment from short circuits and overloads. Thirdly, circuit breaker disconnects are used in applications where both disconnecting and overcurrent protection are required. These disconnects incorporate a circuit breaker to provide overcurrent protection. Fourthly, manual transfer switches are used to switch between two different power sources such as utility power and generator power. These switches provide a safe and reliable means of transferring power from one source to another. Fifthly, automatic transfer switches are similar to manual transfer switches, but they automatically switch between power sources in the event of a power outage. These switches are commonly used in critical applications where uninterrupted power is essential. When selecting a disconnect, it is important to consider the following factors. Firstly, the load current. The disconnect must be rated to handle the full load current of the equipment it serves. Secondly, the voltage rating. The disconnect must be rated for the voltage of the system. Thirdly, the interrupting capacity. The disconnect must be able to safely interrupt the available fault current at the installation location. Fourthly, the environment. The disconnect must be rated for the environmental conditions in which it will be installed, such as temperature, humidity, and exposure to corrosive substances. Fifthly, the applicable codes and standards. The disconnect must comply with all applicable codes and standards, including the NEC and local electrical codes. In the case of the heat pump installation with 15 kilowatt heat strips, a non-fused disconnect switch rated for at least 80 amps and 240 volts would be a suitable choice. The disconnect should also have an interrupting capacity adequate for the available fault current at the installation location. It should be installed in a readily accessible location near the heat pump and properly labeled to indicate its purpose. It is also worth noting that some jurisdictions may have specific requirements for disconnects that go beyond the NEC. For example, some jurisdictions may require that disconnects be lockable in the open position to prevent accidental re-energization of the equipment during maintenance. These requirements should be checked with a local electrical inspector before starting the installation. Finally, remember that electrical work can be dangerous, and it is always best to hire a qualified electrician to perform the installation. A qualified electrician has the knowledge, skills, and experience to safely and correctly install electrical equipment and ensure that it complies with all applicable codes and standards. Attempting to perform electrical work without the proper training and experience can be hazardous and can result in serious injury or even death. In conclusion, understanding the NEC requirements for disconnects is essential for ensuring the safe and compliant installation of electrical equipment. While a breaker lockoff might seem like a cost-effective alternative to a dedicated disconnect, it often does not meet all the requirements of the NEC and can pose a safety risk. Always consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable codes and standards.